Hello everybody. This is the second video on the thermal model. In the first video, we elaborate about the various type of loads and how to calculate the motor ratings. Here we talk about regarding the thermal capacity of a motor, how the motor is classified in terms of thermal capacity, and how the loads are different classes of load, and how we can divide the load in terms of different motor duties. So let us go ahead. So here we will be discussing about the classes of motor in terms of the insulations. So if I classify the motors in terms of the insulations, so they are classified as one is a gamma. Then let me write in a easy way to just remember A. You leave that one in the middle, say B, and leave two terms and say C. Another terms will be here as E. Then here you have F, G out, and H. So how they are classified are, they are classified if a motor is labeled with gamma insulation type, that means it can maximum resist 90 degrees centigrade. The insulation material will sustain till 90 degrees centigrade. If it is insulation class is A, it can sustain 105 degrees centigrade. Similarly, there will be a rise in the value of insulation strength, 120 degrees centigrade. Here it is 130 degrees centigrade. Here again it is 155 degrees centigrade. And H is 180 degrees centigrade. And C is above 180. So C is above 180. So what is the difference? You can say here the difference is 15. Here the difference is again 15. Here the difference is only 10. Here the difference is 25. Here the difference is 25. It's easy to remember. That you can say A, B, C, and then E, F, H. This is the way the motors are classified in terms of insulation. How we are using the motor, what is the current we are giving the motor, how much time duration we are giving the motor, running the motor. Doesn't have any problem as long as the temperature of the machine or temperature of inside the machine will not exceed the rated value. If it exceeds the rated value, it is a problem. Otherwise, you can take the motor and run it in any way. It doesn't have any effect unless and otherwise the temperature rises to a rated value, above the rated value. So class C is as the insulation strength, insulation type is increasing, obviously the cost of the motor will also increase. Another is the we can say classes of motor duty. The classes of motor duty that we will see here, right? And the class of motor duty means how does you relate the loads, work or the loadings of motor. So there can be one is one you can say short time duty. The motor is running for a very short time. You can say the example of machine tool for position control and just opening of doors and some household appliances. These are work for a very short duty. So we can classify as a load which is working for just short time, then keep it for idle for a long time, enough time. So we will discuss in all this. Second is your intermediate loading. MITTENT, intermediate periodic loading. Periodic duty, and we can say the intermediate duty with one is this, and another we can say with starting. That is, starting cannot be neglected. And we can say with starting and breaking. These intermediate loading, periodic duty, that means it is on for some time, then idle, then on for some time, then idle. With starting, then starting is considered here. With starting and breaking, both starting and breaking is there in that particular duration. So, and since it is named intermediate, that means there is a rest period and there is a running period. Third, we can classify as continuous duty. Continuous duty. So continuous duty can have like continuous duty. Another is continuous duty with intermittent periodic loading. With intermediate periodic loading. And we can also say continuous with starting and breaking. Starting and breaking. We can say continuous duty with periodic speed change. So continuous duty is again, so total we can have here different 4 types, and here we have 3 types, and this is 1. So I can have total 8 different types of classes of 8 different types of motor duty, and here I have 3, 4, 5, 6, 7 different types of classes of motors. So now we will discuss about that individually: short time duty, intermediate periodic duty, and continuous duty. Jig catches and how does it works? So let us discuss about the short time duty. In short time duty, the load is on for a very short time. Then you can take it off. Like you can again there is a on after a certain time. Very lot of time difference is there. So let us say TL is a load here, and with respect to time, and I say let us say this is the ambient temperature, and this is the final temperature. This is the final temperature, steady state temperature the machine would have. Now, when we run it for a very short time, it starts with the ambient temperature and rises to a certain value. Then, when we switch it off, it turns off very slowly and it will again settle to the ambient temperature. So the point is that even though we are overloading the load, overloading with TL, the temperature will not exceed to a rated value. So we can go for a overloading, because I want it overloaded. So I can overload it for this time. It's okay, because if I overload it, so what will happen? I will get a temperature change over here. So the temperature may rise up to a certain value, but I must make sure that temperature should not exceed the rated value, and then it should settle down to a steady state value, to the ambient value. This is the ambient temperature, that is surrounding temperature we must maintain, and here is the steady state value. This is a short time duty. Let us take another one, intermediate duty. So here we have intermittent. So let us take another page. So here we have intermittent periodic duty with three different types, and here we have continuous duty with four different types. So let me just draw the axis of these three so that we can easily learn. And here we have a continuous duty. So we have four different types. So let us draw it. The four different types. The change in pen. So let us take a pen. So let us represent load with intermittent duty. The load is like you on for some time, then off, then on for some time, then off. Neither this is very long, neither this is very long. So both on time and off times are limited. And when we say when one is intermittent with only intermediate periodic duty, another is with starting. Here with starting. With starting means that means we have on, then rest, then off. Then we have on, then rest, then off. And another we have here again I will draw one more. On, then rest, then off. And on, then rest, then off. Sorry, not that. Here we have it is intermediate periodic duty only, so it is like this. So here we have time, here we have TL, similarly we have time here and TL. Here we have intermediate duty with starting, running and breaking. We will stop, then again here, starting, running, and again here, break. So like that, we have like starting, running and break. So here with starting and breaking. And here we have continuous load. So you can say continuous load. We can have like continuous load, but momentary continuous load with intermediate periodic loading. Continuous load with intermediate periodic loading. And we have here another option with starting and breaking. That is continuous load. And then with the starting, then running, then breaking, then back to original. Then starting, running, get back to original, like that. Again we have with periodic speed change. So we can have here one with periodic speed change when the speed change will occur. So we can have another speed change like this. So the loads will have, this is a TL, this is a TL, this is a TL. So loading is here for intermediate time. So I can say this is continuous, this is intermittent periodic loading, and this is the starting and breaking. This is with periodic speed change. So quickly let us complete this. So if I have a thermal model, this will rise in temperature, then fall, then rise and fall. Both are not touching the ambient value and the final steady state value. Similarly here also there is a rise, then fall, up to then rise, then fall, like that. So here also we have a rise, then fall, rise, then fall, like that. So here that will rise and steady state follow, and here it will just, so here also you can have like this, and again we can draw a different value. So what ultimately we can say that thermal, this is how we classify the motor duty in terms of short duty, intermittent duty, and continuous duty. And these are all 8 different types.